Huh, okay. All right. Hello, everybody. Welcome to our Telescope Talk Hangout for March 7th. This is the first one for the month of March. My name is Tony Darnell. I run deepastronomy.space, and today we are going to be talking about a certain kind of telescope called a Schmidt-Cassegrain. And it is, we've talked about them a little bit before in a couple past Hangouts, but we've talked about them in the context of other telescopes you can buy, good telescopes for under $1,000, I think, things like that. They're not exactly a cheap telescope, but we're going to talk a little bit about those today. You know, this thing is telling me that that the stream quality is bad on YouTube. So you guys, would you guys comment in the chat box and let me know, because all of my stuff says it should be fine, so I'm not seeing any errors. So please let me know if you are seeing a very bad quality. But we also are streaming on Twitch and Periscope. I'm not streaming on Facebook today because Facebook's been giving me a lot of trouble, and I didn't want to set it up for this, try and get it for this Hangout. So we're only on 3 platforms today. But that doesn't mean you can't interact with us. We are doing it. Oh, good. Peter Quinn says stream is fine. Excellent. Don't know why it's saying that, so I just want to double check. Best way to talk to us today is the live chat's going on YouTube, which is good. Susan Hunter's there. She's from Florida. She's from my neck of the woods. And Michael Denzler from South Germany is online.
That's a friend of mine, yeah.
Is it? Okay, cool.
Yeah, he is.
Good. That disembodied voice you're hearing is one of my co-hosts. Let me bring him up. This is the Telescope Talk cohort, guys. Everybody over there on that side. That side. There we go. I have to point opposite of the screen is on the other side of the pond. So welcome, guys. How are things in the UK/Germany?
Which one? Weather's bad.
You know, everybody's got beer. See, good.
Yeah.
Good. Everybody, these guys know how to have a hangout. I need to learn from them for sure. Me, I just have my regular old sweet tea. So anyway, the reason my video is a little bit washed out is because I'm using a webcam today, because I also want to hook up Stellarium, and I used my video capture card for that today. So I'm going to be switching to Stellarium here in just a little bit. So, you know, guys, I was watching, a lot of the news reports out there. Can you guys buy bread now in the UK? Apparently, all your shelves were empty. There was this picture. There was this picture of all the empty bread shelves in Asda. Can you guys buy?
Yeah, there's a kind of panic buying spree for some reason.
Was it panic buying because the weather was so crappy out there?
Well, it seemed to be.
Yeah. Okay. Yeah, and in the U.S., there's more bad weather in the Northeast. Not here, of course, because I live in Florida. But in the Northeast here, it's also got another round of bad weather happening. So settle down, folks. Cozy up to this hangout, and let's talk telescopes. So just so I can give you the names, up in the top left is Alexander Reinders. He's from Germany. Excellent amateur astronomer with lots of experience in imaging and being an amateur astronomer. In fact, everybody here, we've got years, decades, lifetimes of experience here in this hangout with amateur astronomy. So if you have any questions at all, we're your people. Okay, right next to him in the upper right is John Suffill. He's from the UK. Also down below, Adam Synergy Smith, drinking his
I'm
pint.
on the milkshake today.
You're on the milkshake. Oh,
yeah,
all
behaving.
Right. Also, 2 UKs, a Germany guy, and an American, all here to talk about Schmidt-Cassegrain telescopes. All right, let's get started. Let me pull this up. Schmidt-Cassegrain telescopes look like this when you draw out the light path of the design of the telescope. They are a kind of telescope that you see everywhere, mostly in amateur astronomy magazines. Almost every amateur astronomer at some point or another owns a Schmidt-Cassegrain. But the light comes in from the left and goes to right and hits that big primary mirror in the back, which has a hole in it. And then reflects up into a secondary mirror, which is often to the left, and then it goes, that secondary mirror reflects the light back down through the primary mirror, which has the hole in it, to an eyepiece. Now, this is a very simplistic view that the very first piece of glass that you see on the outside of the tube is actually a pretty complicated piece of optics. That is a corrector plate, and it is designed to make the wavefront such that when it hits that primary mirror in the back, which is a spherical shape, it's not a parabola like in a Newtonian, then it reflects properly without a lot of distortion on the edges of the field of view to the secondary mirror, which is also a spherical curve, but it's it's convex, not a concave curvature, and then goes down into the eyepiece area. That's a Schmidt-Cassegrain. It's developed by two guys, Schmidt and Cassegrain. And a long time ago, that's right. Now, these were not commercially possible, really, to make in any kind of inexpensive way until Celestron came out with one in the 70s. Celestron was one of the first manufacturers of these telescopes. And what the secret to their sauce was, they were able to make that corrector plate at the end very inexpensively. They had patented a technique that allowed them to make that corrector plate in a way that was very inexpensive, because anybody can make a spherical lens. Spherical lenses are real simple to make when you're grinding. But basically, if you grind a mirror in any way at all, you're going to end up with a sphere. If you go back, and most mirrors are ground in a back and forth fashion or a certain pattern, spheres come out more or less naturally. So spheres are easy to grind, but a parabola is a lot more extra work. So making a sphere is not such a big deal, and in fact, a lot of refractor lenses, these are refracting lenses, clear glass that light goes through. A lot of the surfaces on the convex mirror or convex lenses are spherical in shape as well. It gets more complicated with different kinds of apochromats and different kinds of lenses there, but by and large, spheres are easy to grind. And so the hard part in the Schmidt-Cassegrain design was the corrector plate, and Celestron was the first one to figure out a cheap way to do it. And you could buy an 8-inch Schmidt-Cassegrain from Celestron back in the 1970s for about $1,500, and that was 70s money. But if you look at how much you could buy an 8-inch Schmidt-Cassegrain for now, or 70s money, it's not that much more expensive. Telescopes have not gone up that much in price over the decades. Would you guys agree with that statement? Think about it. You could buy an 8-inch go-to telescope that will do everything but make your eggs in the morning for about $2,000, right? I mean, more or less. I mean, that's not much more expensive than they were back in the 70s.
Yeah, and the technology has only got better. Telescopes have got better.
Yeah, and the manufacturing techniques have gotten better. Now, the big competitor for Schmidt-Cassegrains is Meade, and Meade also does a very good job. I don't know how they got around the corrector plate issue. Maybe they came up with their own way of doing it. I'm certain that Celestron didn't let them use their patent, so I'm sure they figured out some way around the corrector plate issue and was able to make decent, very high quality Schmidt-Cassegrain telescopes. So, all right, guys. Now, Alex has one right behind him. That's a C11.
11.
That's right.
Yeah, Celestron.
So, how do you like it, Alex? Tell us a little bit about your C11.
Well,
and what do you hate about it?
I hate about it. Hasn't got a mirror lock, by the manufacturer. So yeah, you got to install it by yourself, or you have to let it installed. And Meade is better in that way. They had the mirror lock patent for the last 20 years, and yeah, the optics was just better, but it was heavier. So Celestron was lighter, but not accurate as the Meade optics were.
So what did you say about installing? I'm sorry, my audio isn't as good as I'd like it to be, my earpiece here. What did you say about doing it yourself? What did you have to do yourself?
Well, let me turn it on. the construction, when you move the telescope, the mirror is moving by itself. Is not always aligned exactly.
Oh, the focus.
Corrector
I
plate.
see the alignment. I see what you're saying. Okay, thank you. Yeah. So
These little two guys can fix that, or they can,
okay.
the mirror in position. So
Okay.
it doesn't move compared to the alignment to the tube or to the corrector plate.
So that goes into the what's not so great about SCT's category. Schmidt-Cassegrain's focus by moving the entire primary mirror back and forth on a rack, and you turn a knob at the back, and when you're not moving the eyepiece like you do in most telescopes, like a Newtonian or something like that. You're moving the whole primary mirror up and down, and they never get that right. Sometimes what happens is it shifts a little bit. You'll get a slight, I'm doing this like you can see what I'm saying. Let me move this over here. So if this is the mirror, it might go, it has a lot of, it might have some play this way. So if you're moving, what you want is ideally you want that mirror to go up and down smoothly with zero movement. But you never get that. You get a slight little offset a little bit that screws up the image quality. I mean, it's, you'll get, when one part of the mirror isn't lined up perfectly with the other part of the telescope, then you get crappy images, especially toward the edge of the field of view. So that's a big minus for Schmidt-Cassegrain telescopes. The focusing is always done in a way that moves the entire primary mirror. And to me, that's a con. That's a disadvantage. But you overcame, and that means you periodically have to align the optics manually, like Alex was saying. You have to collimate it. And
but it's not easy.
And it's not trivial. So if the alignment comes out, they give you these little Allen wrenches to adjust the secondary mirror, but you still sometimes have to figure out a way to get that primary less loose on its track. Do you ever, guys? Now, John, you have a Maxutov, which we're going to get to in a minute, but the situation is similar. Do you guys ever have to open these things up? Like, do you ever have to take the corrector plate off?
Yeah, I have.
You've taken yours off? What about you, Alex?
I did, and you got to make a kind of mark where the alignment for the corrector plate is aligned relatively to the main mirror. If you move it a bit, we won't have any good picture anymore, because the corrector plate is just done for that mirror, and you can't exchange it with another corrector plate, for example.
So if you ever do take it off, you've got to put it back on, not only the right way, you don't want to flip it back, but it's got to be exactly where it was before. So you need to make sure you...
The right twists,
Okay. All right, well, we've talked about some bad stuff. What are some great things about Schmidt-Cassegrains? To me, top of the list, portability. They fit in a small case. I love that about them. What do you guys like about them? What other pluses?
You got a very long focal length telescope in a very short stubby tube. In my Maxutov telescope, well, I can't get my hands in. It's only about that long, but it's about 1.5 meters in focal length.
That's right. So they have a long focal length for their size, and that's because they're folded back. If you go back to this diagram here, you can see that the light comes in here, and then goes all the way back, bounces off here, and then comes up again, hits the secondary, goes all the way back down here. So for a given length of the tube, which would be from here to here, that distance, you can have a short, squat tube, but a really long focal length. I remember we talked before about what's so great about long focal lengths is that they give you high magnification, narrow fields of view for things like planets and other things. So that comes with it. They're long focal length. They're compact, relatively lightweight. I mean, Alex was saying that the Meads used to be heavier than the Celestrons, but now they're all really light. Celestron, though, back in the day, they used to make theirs out of sand cast mounts, which were pretty freaking heavy. And there's a lot to be said for heavy, because like we've talked about before, when you're imaging, you don't want a lot of vibration. You don't want light optical tubes blowing around in the wind. So there's a lot to be said for weight until you go to carry it around in your car. Then you're wishing you had something a little bit lighter. So, all right, what other things do you guys like about Schmidt-Cassegrains? Do you use yours a lot for imaging, Alex?
Not anymore. It's very difficult, and F10 is not easy to for imaging. For faint objects. I like faint objects. What I really like it for is for observing, for visual astronomy with binoculars, with a binocular attachment like here. You get a 3D image, for example, of the moon. You get a spacewalk effect if you watch it with a binocular adoption, watching the moon, the craters and stuff.
So you like using them primarily to visual use, then, with
visual use
with the binocular
for planets, for the moon, for the sun.
Okay, they're not great for. They are okay for imaging, especially if you want to image planets and stuff. But I'll tell you, when I had my LX200, the most valuable thing I had purchased for it was a telecompressor, and that was the thing that cut the focal length down by almost half. And the reason I needed to do that was because these cameras are already very, very tiny fields of view, and I needed a wider field of view to match the pixel scale of my camera. So I had to buy a telecompressor, which meant I wasn't even using the focal length that came with the telescope. The first thing I had to do was defeat that by buying a telecompressor. So, the best thing about it, though, was it was mounted on a go-to mount, and I could just type in, M51, enter go-to, and then off it would go, and there it would be, and I could image. But you can get go-to mounts now for all kinds of telescopes, not just Schmidt-Cassegrain. So, yeah, not great. I mean, they'll work for imaging really well, but for what you're paying for them, I'm not sure. Boy, we're coming up with a lot of minuses. So they're expensive. They're heavy. They are hard to align. Focal length could be a plus or a minus depending on what kind of imaging you use, because they are a long focal length. And can we think of some more pluses, things we like about Schmidt-Cassegrains?
You can use them for deep sky imaging.
Right,
brighter objects, yeah.
For what?
For brighter objects, easy.
Yeah,
brighter objects, yeah.
Yeah, M42, the Orion Nebula would be good. M51, Whirlpool Galaxy would be nice. A lot of things look the Crab Nebula, the Ring Nebula, those things look really, really well and really, really good in there. And another thing they're good for is, and I don't know, this is an added level of expense, and we talked about this briefly when we did the solar eclipse hangout, but you can attach an H-alpha filter, that's hydrogen alpha filter, to one of these telescopes and have some superb solar imaging through one of these. But you've got to have that filter to do it. And hydrogen alpha is a I think it's I forget the 6562, I think, angstroms is the wavelength that it looks at, and it's in the red part of the spectrum, and it lets you see things like filaments and active regions and prominences and all kind of great solar activity. These telescopes are really, really good for solar observing.
You wouldn't just use that filter, though, would you, Tony?
What's that, John?
You wouldn't just use the hydrogen alpha filter.
You just use the hydrogen alpha filter?
You would not just use the hydrogen alpha filter.
Oh, sure you would.
On the eyepiece.
Huh?
Over the eyepiece.
Yeah. Well, okay, so there's a thing you put over the tube to knock out most of the light, because you don't need is that what you're getting at? Oh, yeah. Yeah, they come with a one of those solar filters that basically throw away 98% of the light, and then you what you have left you send through the but they're not a standard like solar filter like what you buy. They're a block. They're a filter block that basically throws away most of the light except for the red, and keeps the red part of the spectrum in, so that the H alpha filter can do the rest. But it's not like your normal visual solar filter that you would buy. So I guess I look at all of that as a unit. When you buy one of these, you get that pre-filter, and then you put it in your eyepiece, and then you look at it. So yeah, you do look straight through the eyepiece with it using one of those, and those are great for taking images through as well. We're going to do a hangout on the Coronado personal solar telescope in future hangouts, because I have one of those and I use it a lot, and that's a visual only H alpha telescope. Any other good uses for Schmidt-Cassegrains? Oh, another thing we're going to do with these hangouts is I want to try and do different segments, and I want to do 20 minutes on this telescope, and then we're going to move and we're going to talk about what's up in the night sky. But before we finish up, anything else we want to say about Schmidt-Cassegrains? Would you recommend them to a beginner?
No.
I don't see why not.
You've got the money, right, John? Yeah, they are expensive. I mean, you're looking at $2,000 for an 8-inch, with the mount and everything else, of course. It's a complete system, but it's still quite a bit of money. Your C11, did you buy just the optical tube?
Me?
Yeah. Did you buy the optical tube, and then you put it on an equatorial mount, didn't you?
At first, when I bought it in 2009, it was a second-hand CPC 1100. It was on a computerized fork mount, and it was perfect. It was a perfect steering, but it was just too heavy to setting it up always for having, for example, making pictures or observations with the lens telescope. I always had to set up first a big fork mount with about 32 kilograms, and then for using just a little lens telescope. And so I changed it to this mount. I off the fork. I'm just using the tube. I put some white foil on it because you got less temperature problems if you let it out in summer, for example. If you having it standing outside, and it's just not heating up much. It was a black one, and now it's a white one now, and much easier to handle with about 13 kilograms instead of 32 kilograms before.
Okay, and so you can get them in different configurations, not just a fork mount like you see a lot in telescope magazines and stuff. But they're not. I hesitate to recommend them as a beginner scope, only because of their field of view and the image quality that they end up doing at the higher magnifications. You really need a good mount. You need to have some experience before you can get the most out of these. So I guess, I don't know. I'm hesitant to recommend them to a beginner. Somebody has some really bad sound coming out of here.
John sounds bad.
All right. Hopefully it'll go away soon. If not, you guys may have to mute yourselves until you guys want to talk. All right. Well, that's Schmidt-Cassegrain telescopes, and they are, as we said, because of their price, they're not exactly a good way to go if you don't have a lot of money. But they do have a lot of advantages for if you are a visual observer. They are really nice. I recommend them like Alex does as a visual telescope. You'll get the most enjoyment out of those. For imaging, we've talked about before and what you need to get these done. Most of us, I think, are going for the wide field telescopes. We like things like Newtonians and Dobsonians, which are Newtonians mounted on a special mount. So we like a lot of the wide angle, large field of view, short focal length telescopes for imaging. So I don't know. Anything else you want to say on Schmidt-Casses? No? You guys are done? You guys, you said all you want to say on it, right? All right. Okay, so let's move on to I want to talk a little bit. Let me just see. Yeah, bad noise. I think it's John Suffill. His window is flashing. Oh, that's Peter Q saying that. Okay. By the way, I'm on Discord as well, folks. If you want to get on the Discord server, I would appreciate it. Let me look through real quick at some. Do you guys see any questions before I go to the what's up tonight? John Michael Jobin, I got an 8-inch used for $1,000. That's right. We've talked about that plenty of times, haven't we, John? About getting things used.
Oh yeah, nothing wrong with getting second hand. As long as it's preferable to actually be able to see the thing before you buy it.
Yeah, you really do want
to. Blind.
Yeah.
Yes.
The corrector plate is this is for just looking. The corrector plate is in the hole of the primary mirror. No, the corrector plate is that glass plate that is over the end of the tube. Okay. If you look straight through a Schmidt-Cassegrain optical tube, the first thing you're going to see is a piece of glass, and then you'll see a black ring mounted in the center of that. That piece of glass is the corrector plate, okay? And the thing behind it, as you look toward the other end of the tube, is the primary mirror. So it covers the whole tube. It's a sealed tube, essentially. So that's a good question. Just looking. So that, yeah, good. Okay.
There's an alternative to the Schmidt-Cassegrain. That's the Maxitov.
Oh yeah, okay. Let's go ahead and talk very briefly about Maxutovs. What's the difference? A Maxutov Cassegrain is the same basic design as a Schmidt-Cassegrain, except it has a different corrector plate, right? Right, John?
That's right. Yeah. If you can bring up Alex's telescope.
Yeah.
Placing it straight at the.
Let me make him big. Let me make it. Whoa. Stop doing things. Exit full. Hang on, it went big. Okay, let me go speaker view and let me go Alex. There he is. All right, so Alex.
Right. You see the corrector plate at the front.
Yes.
That bit in the centre, that's got screws in that you can adjust. That's on the Schmidt-Cassegrain.
Here we are.
Yeah.
That's right, yeah. On the Maxitov Cassegrain, it does away with that, and the back of the plate is silvered. The back of the actual corrector plate is silvered.
Oh, right. And so instead of that big black mounted secondary mirror, the corrector plate part, the glass plate part in front, has a silvered surface on it that is the secondary mirror.
Yeah,
and
that's right. Yeah,
and that makes them for
something.
And that makes for a slightly cheaper telescope, but everything else is the same. The focal lengths are
exactly the same design, and it's not just a bit cheaper. It's in some cases considerably cheaper.
Yeah, you can see Maxutovs for a 5-inch or 7-inch. You can see them for under $700. They're not too bad. They're not they're more reasonable. And why would you buy one over the other guys? Any reason?
The Maxutov are better corrected than Schmidt-Cassegrains in the field of view.
Say it again, please, Alex.
The correction of the field of view on Maxutovs is better than on Schmidt-Cassegrains.
Oh, okay. So the field of view is
for
better.
Imaging, Maxutovs are better.
Okay, all right, and they're also less expensive. So I've never owned a Maxutov. I've only owned Schmidt-Cassegrain, so I can't speak from direct experience what the image quality is like. But yeah, they definitely have the advantage of being.
You get a wider field of view with a Maxutov. Is it just about the same?
I've never really compared it with the Schmidt, so I can't really say.
No.
Yeah. Peter Q's asking, will it work with a connecting camera for pictures? Yeah, both of these will.
It works.
All of these will work, but they have long focal lengths, and so you're going to get narrow fields of view, and they're more difficult. But yeah, all of this can be used for imaging. It's just not the first choice for imaging optical design. Okay, well, good. So Maxutovs are something we're going to talk more about, I think, in future Hangouts because there's just so many different kinds. And what I'd like to do with this Hangout series eventually is to actually get some of these telescopes so we can review them for you and let you know what we think. But that's a little bit further down the road. So for now, we just have to tell you in generalities what the advantages and disadvantages of these different telescopes are. What do you got going here? What is this?
This is the imaging setup of the Schmidt-Cassegrain of my C11. As it used to look before, it was on the fork mount, on a CPC mount. Very, very good steering. I really do miss that. It's not comparable to other steerings on other mounts, and on the computerized mounts. It was very, very good. I'm really missing it, but I don't miss the weight of that huge fork.
Yeah, that was a lot of carrying. That's a lot of weight to carry around. You look like you have it mounted on a. Is that a pier? I can't see. What's the equatorial wedge mounted on?
Yeah.
Oh, okay. Yeah, it's a pier.
It's a pier, and here the wedge, and this is the fork. It's very, very stable. It's perfect for the C11. Hold it, and yeah, it was just a weight that made me changing the mount.
Is that telescope polar aligned?
It is, yeah.
Okay, folks. Look, I want to just show something about this picture for a minute. Let me pull it up big because I want to make a point. Look at, basically, Alex has no northern sky. He has very little northern horizon in this particular setup. Yeah. And that's okay, because if you think about how the sky moves, and I'll show you in Stellarium here in just a minute, you really care about a southern-facing view, and that's what he's got here, because the fork mounts are pointing toward the North Star, which is basically where the building is, and he's got a really, presumably, an unobstructed field of view toward the south. That's way more important. And we're going to talk about observatories in future Hangouts, but this as an observing site, if you've got to make a compromise, let's say you're going to buy a house and you want to be, and you're a really avid amateur astronomer, the very first thing you should do is look at your southern sky and see how good it is. If you can get a good southern view, you're golden. Why? Because, well, the sun, the moon, the planets, they all travel across the ecliptic from east to west, and you get a good view toward the south that way. All of the seasonal constellations like Orion and Scorpio and all of those also appear in that area of the sky. You just may have to wait for a certain season before you get to see certain constellations, but you can see almost everything. What you're denying yourself with a setup like this is anything around the North Star, and that would be all of the circumpolar constellations, which, let me go ahead and use this as a segue. So I have here, this is Stellarium. Hopefully it's reasonably viewable in this stream to you guys. I hope you guys will tell me if it's unreadable. But what I have here is, you can see that I'm looking south right here. That's because most of the interesting stuff is in the south. Now, this is right after sunset in my latitude in Florida. And you can see there's Orion, the Hunter is up, Canis Major, Sirius is here. If I go a little bit to the west, the Hyades and the Crab Nebula is setting in the west. It's still very viewable right after sunset. This is right after sunset. So a lot of the interesting stuff in the night sky occurs toward the south. So what are you giving up? Let's go over here to the north. This is what's up tonight. There is the North Star, Polaris. Oops, it's not pointing to Polaris. There, that's Polaris. It's the end star of the Little Dipper. There's the handle of the Little Dipper, and there's the 4 stars that make up the Dipper part. And so it is, and all of these stars here are what you're missing. Cassiopeia is low in the horizon right now. The Big Dipper is starting to rise. There's the Big Dipper up here. So you're giving up all of this stuff. As the night progresses, let me just go this way. You can see. Oops, I'm going the wrong way. Oops. Let me make sure I'm going the right way. Which way is east? That way is east. So yeah, I was going the right way. So as things travel, as the Earth turns, and it's on its daily axis, the stars all go around the North Star, and so Alex, from that viewpoint where we saw his Schmidt-Cassegrain setup, he's missing this. This is what he's not seeing. but he is getting a lot of other really interesting things. And if he waits long enough, like the moon is starting to come up now, he would be able to see it a little bit later on. This is 1 in the morning local time, so about 5 a.m. UK time, or 6 a.m. The moon is starting to rise. So that's an important point about the night sky and what you can see at given points. I'm always amazed at what amateur astronomers can do with the constraints of their property. And Alex, I don't know if that was your home or not, but where you looked like you had a permanent pier set up in that balcony.
It is a permanent pier, and it's, yes, it was on a wedge, and now I'm using a more flexible system. You know, I can use my C11 for putting it in my smart car and driving somewhere else if I want to see, for example, the North Sky somewhere. I can pull it up on my car and just travel.
I love that. I love that image. Yeah, there's a smart car. That's your most versatile way. You can drive anywhere in England and in Europe with a setup like this. But the advantage, guys, of having that set up on the balcony is that you can just decide after you have tea, you may just go, you know what, I think I'm going to go out and observe with the scope, and you just in 20 minutes you're up and observing. Whereas this other way, you've got to drive, figure out where you're going, and everything else. But so these are really really nice portable ways to this way you're always assured of getting a decent night sky. So Peter Q wants me to comment on meteor showers. I was wondering what they were and why they were moving so fast. So I don't think there's a meteor shower scheduled anytime soon. But anybody want to take that question? Or you want me to do it? I'm doing a lot of talking, which is the reason I'm...
I can't remember when the next one is.
Yeah, I think is it the Geminids might be next? I forget. But anyway, throughout the year, periodically, there are meteor showers. And basically, they are areas in the Earth's orbit where a comet has traveled through and left some debris. And each meteor shower, from the Orionids to the Leonids to all these different ones that you hear, can be attributed to different comet debris fields that the Earth passes through. And they can be quite spectacular, but as the Earth moves through that debris field left behind by the comet, all those little bits of grains of sand and dust, and in some cases pebbles and rocks, burn up as the Earth travels through that field in the atmosphere. And they show up as bright streaks from a certain region of the sky, and that happens to be wherever the Earth is traveling toward at that moment. So they're characterized by two things: the area of the sky, the constellation from which all of those streaks appear to come from, and they're also characterized by the name of the comet that left the debris field behind. So that's what they are, Peter Q. He wants to know in stellarium. Well, stellarium, that's just, you can set stellarium up to randomly show streaks in the sky. It's just a artistic effect, really. Yeah. So that's okay. So anyway, here's what's up tonight.
The Lyrids, Tony, is the next one. The next meteor shower.
The Lyrids. April
the 22nd, 23rd. It's not a very bright one, though. It's not a very spectacular one.
Yeah, and what depends, what tells you whether they're any good or not? It has a lot to do with how recent the debris field is and how much fun stuff is in the comet debris field.
Perseids are a good one. They're not until August.
Yeah, the Perseids, I think they happen in fall, and they tend to come out of the constellation Perseus, which is up in this area of the sky. It may be set. In fact, it is. Perseus is. No, there it is. I'm sorry. There's Perseus, right up here. So there's the constellation Perseus. So if you're going out tonight and you want to just with your naked eye, without any kind of telescope at all, The big views this evening are going to be Orion, right up here. Betelgeuse, right up here, is a bright red supergiant star. And if you get a pair of binoculars out and you zoom in a little bit, you can begin to see a fuzzy patch down here in the sword of Orion. That would be the Orion Nebula. That's a stellar nursery. And if you have a really nice telescope with imaging capability and you go in enough, you can start to see the Horsehead Nebula right here. But you really can only see, this is not an object you can see with your eye because, first of all, this star is very bright and ruins your ability to see any of this very faint nebulosity here. So this is generally only seen with photographs or images, not with your naked eye.
It is theoretically possible to see it with the naked eye. But you need a very dark sight, very good seeing, and bloody good eyesight as well.
Yeah, you would. I've never seen it visually. I've only seen it photographically. So another really interesting area of the sky tonight is here, where you'll see right next to Orion, he is fighting Taurus the Bull right here. And the easiest feature for Taurus is this V shape of stars. Let me zoom in a little bit. So that V shape of stars is an open star cluster called the Hyades, and it makes a V is the easiest way to find it. And that Aldebaran, that bright red star there, is the eye of the bull. And then you can see two horns. Okay, so they're really big horns on this bull. They go way up this way and up to the V. And if you are this star here, very close to this star is a nebula. You can really only see it with a telescope, but it's the Crab Nebula is here. I have to always do this. I have to do a search, type in M1. It's the first Messier object there is, and you hit go. There it is. It's right there. And that is a supernova remnant. You really need a telescope for this. You can't see this without with a pair of binoculars or through your naked eye. But there is where it's located in the sky relative to Zeta Tau. So, and there is the open cluster of Taurus the Bull. What else can I show them, guys? Anything else that's out tonight that we should point people up to?
Galaxies in Leo triplet, for example, M65, M66, and NGC something, Leo triplet.
Let me go in M65. Let me just do that one. Is that a naked eye object?
A naked eye not, but a binocular object.
Let's zoom in here. So this is a galaxy.
Yeah.
Yeah, and
it's actually 3 galaxies, and you can see the 3 in a binocular.
You can see all 3 of them with binoculars, did you say?
Yeah.
Okay, good. So there's another thing to keep an eye out for, folks. And, of course, the moon will be rising very early in the morning, so you want to get this out. But this is the sky before the moon comes up. Things will be pretty dark and before the moon ruins everything. I should mention that Sirius is the brightest star in the night sky. It is a double star, actually, and it's only about 8-9 light years away. But it's very, very bright in our night sky. It's not physically the brightest star in the sky, but it is apparent. The apparent brightness makes it one of the brightest in the sky. So,
is Jupiter up, Tony?
Jupiter. When is Jupiter up? It doesn't come until
second half of the night. Yeah.
Yeah, it doesn't come up until much later. Let me put the sky forward here.
I think something around 2 o'clock in the morning.
Yeah, where is it? There it comes. There it is. So Jupiter starts to rise at about midnight Eastern time. And there it is low in the sky. So you'll be able to see it coming in the east very early in the morning. So if you stay up late, there'll be Jupiter coming up as well. Okay? And so yeah, good. I just wanted to. I don't know. Give me feedback, guys. Let me know what you think of this. This is something that I want to do with these hangouts. Just spend a little bit of time talking about what's up in the sky, what you can see with your naked eye. Don't have to spend a dime. Just go outside and look up. What are some of the things you can see? So let me know what you think of that. What you think of that idea. And if you don't like it, we'll do something else. Okay. What about any comments? Have you guys been following the live chat?
Mm-hmm.
When is Achilles 308? When is the Humanity Star going to be visible in North America? What is that? Oh, is that thing they launched that it got all the astronomers pissed off?
Yeah, you can check on their website, Humanity Star, and it will tell you when it's passing overhead.
Yeah, I'm sure there's a website that lets you look at that. There's also one for the ISS as well.
HumanityStar.com, I think it is.
Do what now?
HumanityStar.com.
Ah, well, there you go. And that'll tell you right there. Michael
It's
Joker.
currently over the Arctic.
It's over the Arctic.
Yes.
Boy, that was funny though, wasn't it? When all those people started, all those astronomers started complaining about space junk and space graffiti and everything else. They were not happy about that. I didn't even think about that after it launched. It was like, yeah, I guess that's a good point. It's just going to be spewing light.
I think it's only going to be up for about 3 months.
Huh?
It's only going to be up there for about 3 months.
Yeah, it's going to fall back down, but at least while it's up there, it's going to be making a lot of
streaks.
Yeah, a lot of reflections and stuff. Achilles 308. The Chinese space station is falling out soon. Would be a sight. Yeah, well, I guess, but I don't want to be around. If I can see it, that's a problem. I think it's supposed to hit in the ocean, I believe. So, yeah, I don't.
Hopefully.
Yeah, hopefully. It's hard to know for sure. Michael Jobin, 4.5-inch Orion scope with a 40 millimeter Plossl eyepiece, and I can see the Andromeda Galaxy faintly, but I can see it. That's right. That's a 4.5-inch scope. Good job. Really nice. I'm glad you went out. Yeah, and the thing about that, Michael, is that when you're looking at the Andromeda Galaxy through an eyepiece, you're really only seeing the central core of that galaxy. The actual galaxy is extending well out of the field of view of your eyepiece, so it's huge. I think it's something like 6 degrees across the sky if you could see the whole thing, and a half a degree is your thumb held out at arm's length. So that's like, what is that? 3s or maybe it's 6 full moons, man, and it's 3 degrees.
Six full moons.
Is that what I'm thinking of? It's 6 full moons, and so that means it's 3 degrees. So yeah. Someone has a fan on, probably. Michael Denzler, my favorite is a 3-lens APO Fraunhofer. It's a perfect all-arounder. A Fraunhofer. Is that an Apochromat? Is that an APO? Apochromat?
This is a design from Fraunhofer in the early 1900.
Fraunhofer, I've never heard of that. So, but it's a refractor, right?
Yeah, it's a refractor design.
It sounds really expensive, Michael. I'd like to see a picture of one of those.
Apochromatic.
Yes.
I guess that's what APO. Yeah, that's what APO means. So
directed on red, green, and blue.
Nice.
That's APO. And if you want to see the whole Andromeda Galaxy, you have to use the first scope from Celestron. It's a 300 millimeter focal length. Use a 70-degree ocular, and you will see the whole galaxy. It's an f4 3.9 optics, so it's very bright. It's very good, and it's actually a beginner scope for $80 or something.
Cool.
Yeah.
And you can see, and you can see. Well, that sounds like just what you would see with a pair of large binoculars.
Not for binocular, but yeah, use a 70-degree eyepiece. It's of course more expensive than actually the scope is, but it's worth to have a look through it. I like it because you can see the whole Andromeda Galaxy with this little scope, first scope, and it's really good. It's a very bright one, a bright scope.
Okay, yeah, that's good advice. So, and again, that has the advantage of being lightweight. It's portable. Yes. Easy to use. So let's go ahead and answer Gaurav Pandy's question. Even though we've talked about this before, I'm a beginner and was thinking thinking about getting a telescope, any tips? We've said yes. First thing, go watch our first hangout where we talked about best beginning telescopes. But real quick, I'll just say don't spend more than $500. And if you're in Europe, that's what is that?
About £350.
About 350 euros, 350 pounds. Don't spend more than that on a telescope. Why? Because you don't know if you're going to like it yet. And if you don't know if you're going to like amateur astronomy yet, we don't want you sinking a lot of money into something that you're not sure you're going to just totally love. And these telescopes also have the advantage, most of them have the advantage of being lightweight and easy to use, which is the second thing. Second tip that we have, make sure it's easy to use. You want to be, if you are looking at this telescope and you're thinking of buying it, whether it's used or at a store, and you don't know how to use it based on how you're looking at it, then don't buy it. Get something like a Dobsonian. A Dobsonian is a style of telescope mount. All it does is it swivels and it goes up and down. And then you look through an eyepiece, and then you focus that eyepiece. That's all you need to know about how to use a Dobsonian, okay? And they're easy to set up. They're easy to use. They're generally very inexpensive. You can easily get a good telescope for under $500. But if you don't know how to use it by just looking at it, don't buy it. Buy a simple telescope. Another option, which you should never discount, is getting a pair of binoculars first. Lots of binoculars. Everybody knows how to use binoculars. You just put them up to your face and you look up and you focus, and that's it. And that's also a good first way to go. You'll be able to see through a pair of binoculars. You'll be able to see the moons of Jupiter. You'll be able to see the Orion Nebula. You'll be able to see detail on I think, well, depending on how good the night is, you should be able to see stripes on Jupiter. And the moon. The moon has got the craters, the mountains, and the valleys on the moon are amazing in a pair of binoculars, especially if you go out at like half moon. Don't go out at full moon because you'll just blind yourself because it's so bright. But that's my advice. Binoculars, Dobsonian, don't spend more than $500, and if it looks too complicated, it probably is. Don't buy it. So there it is in a nutshell. Anything to add, guys?
Yes, if you buy a cheap telescope, you got crappy eyepieces like this one. They're really crap.
Yeah.
And to use a cheap scope with a more expensive eyepiece, you will have much better field of view and much better picture, and you will see much more than you did before. You might be disappointed using these crappy eyepieces, you know. Very narrow fielded, just very small, you don't see almost anything. And with a $100 eyepiece, you are much better. And I think if you buy it used, you can also sell it again, and you will use it on your next scope. That's my advice.
Okay. Good.
Yeah, I'd go along with that.
What'd you say, John?
I'd say I'd go along with that.
Yeah.
Get a good eyepiece.
Yeah, eyepieces.
Like Alex says,
The
ones that come with the telescope are usually rubbish.
Yeah, so let me give you a couple of brands that, at least in America, and they can give you some for Europe. Orion generally is a very good brand of telescope. So if you're buying an Orion Dobsonian, for example, and it comes with an eyepiece, you're getting a pretty good deal there, okay? And if your eyepieces are those things that, actually focus the image in your eye, so they're important. Another one is Celestron and Meade. Those are all excellent brands, and if you buy one of those and they come with an eyepiece, you're getting a good deal. But again, I would probably push you towards a Dobsonian or a pair of binoculars if you've never done this before. And the Dobsonian brands, SkyQuest? No, Lightbridge for Meade, SkyQuest for Orion. I'm drawing a blank, but
Skywatcher.
huh?
Takahashi, I was going to say.
So what are some brands that are out there specifically for Europe?
It's Bada Planetarium.
Skywatcher Planetarium. Okay.
Eye watchers worldwide, yes.
Okay.
But yeah, they are Chinese made.
Okay. And yeah, so you can
So a
still.
lot from there.
Yeah. Okay. All right. So yeah, Cosmic Lettuce is like that eyepiece is almost as big as the scope. Yeah, that was a big eyepiece. You can get some pretty serious eyepieces, and they cost more than optical telescopes that you get.
And it works on small and big scopes, you know. I like this Baader Hyperion.
Yep. Yeah. And I can't speak enough. I really like the Orion scopes too. I think they for the price, and their Maxutovs are really good too, which we'll talk about another time. They're really well priced for what they are, and I like a lot of those too. So anyway, that's watch our hangout that we did, the very first one on the best beginner telescopes, and we'll come back. We'll revisit this a lot. Okay, well, that is, I think, everything I wanted to talk about today. And you guys have anything we should add before we leave? Oh, Uncle Bill, objects like the Pleiades are quite nice in binoculars too. Yes, the Pleiades are also up this evening, and they are behind the on the back of Taurus the Bull. And I would show it to you, except it's gone now from my field of view on my stellarium. Where'd it go? So if we go, let me just show you real quick. So if we go into stellarium and we get rid of that and we zoom in, so there's the Orion Nebula, there is Taurus the Bull, the Pleiades are behind the Taurus. They're right there behind. I always describe them as the flies of the bull because they're flying on the back of Taurus. And the Pleiades are extremely beautiful in binoculars, so I definitely recommend those as well. So definitely check those. So that's another good example. Uncle Bill through a pair of binoculars. And this whole area of the sky is really, you can just grab a pair of binoculars and sit in a lawn chair and just stare at this part of the sky, and you won't be disappointed. There's lots of cool stuff out here. Lots of variable stars, lots of star clusters, things like that to just enjoy while you're out. So definitely, a pair of binoculars is a good idea. All right, guys, I think we're done. I want to thank you guys for taking time out to join us in this telescope talk. Next time, I think we are going to have some more imaging guests. We might have an expert join us to talk some more about who takes really good images. We're going to have in the next month or so, we're going to revisit the idea of using NASA data for your image processing, and we're going to try and have Judy Schmidt join us and talk about some of her techniques. She uses Hubble data a lot. She helped us recently with a problem we had with WWT, and so she's really knowledgeable. And of course, we'll have Gerald and others that work with Juno data back as well. So we're going to be talking more about imaging. We're going to be going back into that in future Hangouts. Right, guys? You guys were quiet today. I felt like I did all the talking.
Typically American.
Hey, now, I tried to get you guys to join in, and you're too busy drinking your pint. I know what it is. I know better. There you go. All right, guys. Well, thank you guys for taking time out. And on behalf of all those crazy guys over in Europe and the UK, Alex, John, and Adam, thank you all so much for watching. And as always, keep looking up.